Good morning, dear students. Last class I told how to find out distance between two skew lines. Even I told about different types of lines in case of three-dimensional geometry. That is, whenever two lines are perpendicular, two lines are intersecting, and two lines are perpendicular each other. Like all these lines, we are calling coplanar lines. At the same time, whenever the two lines they never intersect and they never parallel, like all these lines are called skew lines. Even I told definitions and concept of skew lines I told on last class I told about all this. Today we'll discuss about how to find out shortest distance between the two lines, because last class I told about theorem on shortest distance, that is how to find out distance between the skew lines. Let us today we will solve the problems on shortest distance on between the two lines here. The first question is, find the shortest distance between lines or vector is equal to I cap plus 2j cap I cap plus 2j cap plus k cap plus lambda into I cap minus j cap plus k cap, and one more line is, and or vector is equal to 2I cap minus j cap minus k cap plus mu into 2I cap plus j cap plus 2k cap. Yes. They gave here two lines. These two are skew lines. Between these two lines we have to find out the shortest distance between these two lines here. Solution for this question is, comparing with first two lines like this. First, comparing with the standard form, or vector is equal to a vector plus lambda into b vector. By comparing this standard form, you will get a vector is equal to here I cap plus 2j cap plus k cap here. Here b vector is equal to I cap minus j cap plus k cap. This is the one vector here. Here also comparing with the standard form here, or vector is equal to C bar plus mu into D bar. C vector plus mu into D vector. That is, C vector is equal to 2I cap minus j cap minus k cap. And here D vector is equal to here 2I cap plus j cap plus 2k cap here. It is the one vector and it is the another vector here. Between these two, with the help of this, we have to apply the shortest distance between the two lines. The shortest distance formula here first. Shortest distance formula. Shortest distance is equal to C vector minus A vector dot C vector minus A vector dot B vector cross D vector whole dividing by magnitude of B vector cross D vector. It is we are keeping under modulus because the distance is always measuring in a positive level. Whenever if we can get negative value, then also we must and should consider that value is positive here. That is the capital T is equal. Just you mentioned capital T is the shortest distance. At the same time, we mentioned this equation number 1. First, what we need first? C vector minus A vector. What are you getting here first? C vector minus A vector. Yes. Considered first C vector minus A vector here. C vector minus A vector means 2i minus I cap, minus j minus 2j minus 3j cap, minus k and minus k minus 2k cap here. And also C vector minus A vector dot B vector cross D vector is equal to. Here C vector minus A vector is one vector. Here B also one vector, D also one vector. Totally we have 3 vectors. Between these 3 vectors we are seeing dot and cross. Whenever in case of vectors, if we can say dot and cross, at a time we can consider that value is scalar triple product value. That is, I told about scalar triple product. That is the concept of STP in vectors I told. Now we are applying that concept for this value. That is that formation. Have to apply determinants of square matrices. From C vector minus A vector, collect the coefficients of I cap, j cap, k cap. That is 1, minus 3 and minus 2. From B vector, what are the coefficients of I cap, j cap, k cap? Just to collect them. 1, minus 1 and plus 1 here. The next one is from D vector, what are the coefficients of I cap, j cap, k cap? Just to collect them, they are 2, 1, 2. Because I cap coefficient is 2 and j cap coefficient is 1 and k cap coefficient is 2 here. Now afterwards, we can expand with respect to first row. Plus 1 into deleting row, deleting column, you will get minus 2, minus 1, minus 3. Already minus is there, minus of minus plus 3 into corresponding row, corresponding column, delete them, then you will get 2 minus 2, 0. Minus 2 into deleting row, deleting column, you will get 1 plus 2, 3. Finally, you will get this value is minus 3 plus 0 minus 6, that is equal to, will get here minus 9. That is we have this value is, what we got, this value is C vector minus A vector dot B vector cross D vector is equal to, will get here minus 9. You represent this equation number 2 this. We got the numerator value is minus 9. Next we are going to solving that denominator part. What is the denominator part here? Magnitude of B vector cross D vector. That is, now we are discussing about the value of denominator. That is, consider B vector cross D vector here. Only cross product is there between these two vectors. That is, we have to apply that formation. First written by I cap, j cap and k cap here. And first second row is written by coefficients of ijk. What are the coefficients of ijk here? 1 minus 1 1. D vector, what are the coefficients of ijk from D vector? 2 1 2 2 1 2. Expand them. I cap into directing column will get minus 2 plus 1, minus 2 down minus up, minus 2 minus 1 minus 3, minus j cap into 0 plus k cap into 1 plus 2 3, because 1 by saying this just deleting row deleting column will get 1 plus 2 3, that is minus 3i cap 0 leave it plus 3k cap. Then magnitude of b vector cross d vector is equal to here square root of minus 3 whole square means 9 plus 3 square means 9 is equal to totally you are getting 18 square root of 18. It is equation that is otherwise you can consider like this, or you can write magnitude of b vector cross d vector is equal to square root of 18. Equation number 2 this. Now put question number 3 here. Put equations 2 and 3 in equation number 1. Equation 1 is equation 2 is minus 9 and equation 3 is root 18. Put these two values in equation number 1, you will get a shortest distance between the two lines. Put equations 2 and 3 in equation 1, that is d is equal to equation from equation 2 we have this value is minus 9, from equation 3 we have this value is root 18 can be written root 18 can be written as 9 into 2, putting modulus is equal to 9 by square root 9 is 3, root 2 here 3 1 ja 3 3 ja is equal to here 3 by root 2 units. Otherwise multiplying and dividing with root 2, then you will get d is equal to 3 root 2 by 2 units. Like that we are finding a shortest distance between the two lines. First we comparing with the lines with standard forms, and what we need the vectors for the shortest distance formula, we must collect those vectors from these two lines, then afterwards we have to apply this procedure. Next, whenever the lines are in Cartesian form, how to find out shortest distance between the two lines here? That's we discuss now. Find the shortest distance between the two lines. X plus 1 by 7. Second question is x plus 1 by 7 is equal to y plus 1 by minus 6. Y plus 1 by minus 6 is equal to z plus 1 by 1. Z plus 1 by 1. Another line is x minus 3 by 1 is equal to y minus 5 by minus 2 is equal to z minus 7 by 1. Z minus 7 by 1. Before this they gave lines in vector forms. Here they are giving in Cartesian forms. When they will give Cartesian forms, already I told we must and should convert these two lines into this form, that is x minus x1 by a1 and y minus y1 by a2, z minus z1 by a3. Like that we must and should convert into that form here. This is the standard form of equation of line in case of three-dimensional geometry. Now let us, we must check those lines whether they are in that form or not here. Let us start the solution for these lines here. The given lines, first you convert into that form, that is x plus 1 can be written as x minus of minus 1 whole dividing by 7, y minus of minus 1 whole dividing by minus 6, z minus of minus 1 whole dividing by 1. This is first one is minus 1 minus 1 minus 1 point is, that's what point means. You considered a vector is equal to minus I cap minus j cap minus k cap here. Next, with the help of direction ratios or the 7 minus 6 1, you considered that is the b vector is equal to here 7 I cap minus 6 j cap plus 1 k cap here. Next, another line is here. You convert this another line also into this form, x minus 3 by 1 is equal to y minus 5 by minus 2 is equal to z minus 7 whole dividing by 1. Now comparing with it is also in that form. First point is 3 5 7, that's what position vector of that point b vector is equal to here 3 I cap plus 5 j cap plus 7 k cap here. Down, direction ratios are there. With help of direction ratios, that is one more parallel line vector, that is d vector. You consider d vector is equal to I cap minus 2j cap plus k cap here, because it is in the form of a vector plus lambda into b vector. It is the form of b vector plus mu into d vector. That is it is in the form of, this line is in the form of like this. This line is r vector is equal to a vector plus lambda into b vector. This is in the form of r vector is equal to c vector plus d vector, b vector here c vector, it is c vector plus mu into d vector. This is c vector plus mu into d vector. Now shortest distance formula here. Shortest distance formula. Shortest distance formula. Modulus of that is d is equal to modulus of c vector minus a vector dot b vector cross d vector whole dividing by magnitude of b vector cross d vector. It is the equation number 1. This is first c vector minus a vector. This is here c vector minus a vector here. C vector minus a vector 3i minus of minus I 4i cap 5j minus of minus plus j 6j cap 7k minus of minus plus k 8k cap. It is we need this vector to find scalar triple product value. Now we consider here c vector minus a vector dot B vector cross D vector is equal to that formation here. First, C vector minus A vector. You collect the coefficients of ijk from this vector. What are the coefficients of ijk here? 4, 6, 8. From B vector, what are the coefficients of ijk here? From B, 7, minus 6, 1. From D, what are the coefficients of ijk from second D vector here? 1, minus 2, 1. Now we expand this. Expand with respect to first row, I will get some value here. Four into deleting row, deleting column, then minus 6 plus 2, minus 4. Next, minus 6 into deleting corresponding row and corresponding column, then we'll get 7 into 1 7, 7 minus 1 6. Next, last one is plus 8 into deleting row, deleting column, minus 14 plus 8, down minus up, 7 into minus 2, minus 14, minus of minus plus 6, minus 14 plus 6 is minus 8. That is minus 16, minus 36, minus 64 here. That is minus 16, minus 36, minus 14, minus 100, minus 116. Therefore, is equal to, it we can write minus 116. That is C vector minus A vector dot B vector cross D vector is equal to 116 here, minus 116. It is equation number 2. Next, we need B vector cross D vector here. Consider B vector cross D vector. B vector cross D vector here. B vector cross D vector. That formation. First written by basic unit vectors I cap, j cap, k cap here. From B, coefficients of ijk, what are they? 7, minus 6, 1. 7, minus 6, 1. From D, what are the coefficients of ijk here? 1, minus 2, 1. B vector cross D vector. Expand with respect to first row, I cap into deleting row, deleting column here. Minus 6 plus 2, minus 4. Minus j cap into deleting row, deleting column. 7 minus 1, 6. Plus k cap into deleting row, deleting column. Minus 14 plus 6, minus 8. That is magnitude of B bar cross D bar, B vector cross D vector, is equal to square root of minus 4 whole square 16 plus, or minus 6 whole square 36 plus minus 8 square is 64, is equal to square root of 116. That is considered, it is equation number 3. Put equations 2 and 3 in equation number 1. Here you can put this equation number 1. Then D is equal to, here numerator part is modulus of minus 116 whole dividing by square root of 116 here. If the positive means it is under modulus, that's what we can consider it is positive value. It is 116 whole dividing by, at the same time 116 can be written as square root of 2 times square root of 116 into square root of 116 whole dividing by, and one more square root of 116 gets cancelled here. Therefore, we can write finally shorter distance D is equal to square root of 116 units. It is the answer for the second question. Whenever lines are given in Cartesian form, at the time we have to apply this procedure here. Before this, I told method, whenever lines are in Cartesian form, lines are in vector forms, at the time we have to apply that method. Similarly, both have same methods. Whenever, if they can give lines in Cartesian form, convert them into vector forms. At the same time, what we need vectors for shorter distance, we have to collect those from the given problem. And afterwards, you have to apply this procedure to find the shortest distance between the two lines. Next, we'll solve some problems whenever lines are perpendicular to each other, how to find out unknown value, and which conditions we have to apply. The given two lines are perpendicular to each other here. Next question is, show that the lines x minus 5 by 7, x minus 5 by 7 is equal to x plus 2 by y plus 2 by minus 5, y plus 2 whole dividing by minus 5 is equal to z by 1, z by 1, and one more line is x by 1 is equal to y by 2 is equal to z by 3, or perpendicular here, or perpendicular. Have to show that the given two lines are perpendicular to each other. Already I told you, whenever if you can see like all these lines in the Cartesian forms, try to convert them into this form, that is the x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, or you can consider a1, a2, a3 also, no problem. For second line, x minus x1 x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. Like that, we must and should convert these lines into that form. Solution for this question is, at the given lines, x minus 5 by 7 is equal to y plus 2 is there. Y plus 2 can be written as y minus of minus 2 whole dividing by minus 5 is equal to z minus 0 by 1 here. There is no nothing, or there is no any number, means we must and should consider as 0 here. Another line is x minus 0 by 1, or you can write it simply, you can write x by 1, that is y minus 0 by 2, it is equal to z minus 0 by 3 here. Comparing with the standard form, that is standard form is comparing with x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1. That is a1 value is 7, b1 value is minus 5, c1 value is 1. Here also comparing with the standard form here, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2 here. If you can compare like this, you will get the values of a2, b2 and c2 are given by a2 is equal to 1, b2 is equal to, and c2 is equal to 3. Now we considered condition for perpendicular two lines. Considered a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This condition is satisfied by any two lines, then we are telling these two lines are perpendicular to each other. That is the a1 a2 plus b1 b2 plus c1 c2. Here a1 b1 c1 are the direction ratios of first line. and A2, B2 and C2 are the direction ratios of second line. With help of these direction ratios, we have to apply this condition. Now we are going to substituting those values in this condition. A1 is 7 into A2 is 1 plus B1 is minus 5 into B2 is 2 plus C1 is 1 into C2 is 3 here. That is 7 minus 10 plus 3 is equal to 7 plus 3 10, 10 minus 10 and gets cancelled is equal to 0. Therefore, the given two lines are perpendicular to each other. If you are not getting 0 with help of that condition, then we are telling they are not perpendicular to each other. Here, with help of this condition, that is A1 A2 plus B1 B2 plus C1 C2, we got finally answer is 0. That's what we can say, these two lines are perpendicular to each other. Based on that, one important question is that at the same time, in case of fourth question, they will give same conditions. At the same time, they mentioned about those two lines, they are perpendicular to each other, but what is the value of unknown? Like that, one question is there. Now let us will discuss about that first one question. That is fourth question is find the value of P. Find the value of P here. Value of P such that the lines first question is 1 minus x by 3 1 minus x by 3 here is equal to 7y minus 14 7y minus 14 by 2p is equal to z minus 3 by 2 z minus 3 by 2. Another line is 7 minus 7x 7 minus 7x by 3p is equal to y minus 5 by 1 is equal to 6 minus z by 5, or at right angle or at right angles. Or at right angles means they are perpendicular to each other. Whenever they are perpendicular to each other, before this I told one condition, that is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. We have to apply this. At the same time, they give lines in Cartesian form means we must and should consider in standard forms. That is, solution for this question is solution. 1 minus x is there, take minus common, then you will get minus of x minus 1 by 3 here. 7y minus 14 is there, 7 take common, then you will get y minus 2 by 2p here. As is z minus 3 by 2 is there. It is also can be written as x minus 1 by minus 3. Y minus 2 by 7 by 2p can be written as 2p by 7 is equal to z minus 3 by 2 here. Here also take 7 common from the second line, 7 take common, minus 7 take common, then we will get x minus 1 by 3p here. Y minus 5 by 1 here. Take minus common here, z minus 6 by 5 here. That is x minus 1 by minus 3p by 7. Here y minus 5 by 1 here. z minus 6 by minus 5 here. Like that we must consider it in the standard form of equations in Cartesian forms. Now compare image. It is x minus x1 by a1, y minus y1 by b1, z minus z1 by c1 here. It is also compare image x minus x2 by a2, y minus y2 by b2, z minus z2 by c2 here. a1 value is minus 3, b1 value is 2p by 7, c1 value is 2, a2 value is minus 3p by 7, b2 value is 1 and c2 value is minus 5. Before this I told one standard condition, that is two lines are cuts at perpendicularly or cuts at right angles. We have one condition, that is consider a1 a2 plus b1 b2 plus c1 c2 is equal to 0. You have to apply this condition here, because the mentioned here two lines are perpendicular to each other. Why I am taking this condition means, already they mentioned about these two lines, they are cuts at right angles. They are cuts at right angles means they are at perpendicular to each other. That's what I have taken this condition. a1 value is minus 3, a2 value is minus of 3p by 7 plus b1 value is here, b1 value is 2p by 7, b2 value is 1, c1 value is 2, c2 value is minus 5 is equal to 0 here. Minus plus 3 is 9p by 7 plus 2p by 7 minus 10 is equal to 0 here. Denominator is same, add the numerators, 9p plus 2p, 11p by 7, send minus 10 that side, it becomes plus 10. Taking cross multiplication, 11p is equal to 70, or p is equal to here 70 by 11, the answer. Like that we are going to finding unknown value from the given two lines whenever they are perpendicular to each other. That's what today I have finished the shortest distance between the two lines, and also the condition for the two lines are perpendicular to each other. Whenever if they can mention the two lines are perpendicular to each other, at the same time if they can ask how to find out unknown value, means we have to apply this procedure. Next class I will tell you about the concept of plane. At the same time we will see that different types of theorems on planes. Thank you very much.